Welcome back to Quainton. This is May, our Peckett R2. Got bought by the Society, I don't know, a couple of years ago. Been a bit of a problem child, this one. Had some problems with injectors and the clack boxes. I'll show you those in a minute. Basically, the injectors had a problem, got taken apart, wouldn't deliver, and we've had to completely re-engineer, redesign, remachine a whole bunch of stuff. So let's go have a look at that. So two problems here. This is the injector. If you've seen the video on how does a steam engine work, we talked about that a little bit before. These are a bit of a different design. One's in R mounted on the back of the boiler. These are actually mounted. There's the water valve here straight out of the tank. There's a steam supplier here. So there's a valve up on top of the boiler. That's the overflow, and that's the delivery pipe through the clack here into the boiler. Dead simple these. There's no delivery tray or anything inside. It literally just gets hoofed straight into the boiler. We'll go and have a look at one of these apart in a minute because there's some interesting gubbins inside here that actually makes it all work. So just to recap, this is a device for getting water back into the boiler against the pressure of the boiler using nothing but steam at boiler pressure. So some clever thermodynamic tricks going on here. Let's go and have a look. So we have on the bench a Peckett injector here. They're pretty rudimentary compared to the sort of railway ones, if you like, for industrial engines, but that's how it sits on the engine. So it's slung under the water valve, and you've got the tank above it. You've just seen that on the locomotive. So this end is your steam supply, that's your water supply there. And get the light, I don't know if it's going to work here. That passage runs down to this end here. So you've got inside here, you've got that steam cone that sits in there. Well, this is a steam cone. So this is a tapered, or dual taper actually, so it tapers downwards there. There's a choke point at its narrowest point somewhere in the middle there, and then it starts getting bigger again. And this is designed to give a kind of like a straight, kind of not like a flame kind of size, like an expanding kind of jet of steam, or like a little pin nozzle one. It's supposed to be just a straight jet of steam as far as you can. That's the idea anyway. That inside here exhausts into, so the two sit together like this, and this gets surrounded by water. So inside here, this is actually a slight press fit inside there, but it sits just down on that little seat inside there. So water all around here, steam blasting through, and the water can enter through here. Now the idea is you've accelerated the steam from boiler pressure. It's come out through here, and it's accelerated up to, in this injector, about 3 times the speed of sound, which if you know anything about Bernoulli's equations, you can tell that as it accelerates, it loses pressure. So it'll be somewhat below atmospheric at this point. So it's creating a vacuum just about here, which actually draws water from that water space in through this cone. Now what needs to happen there, if it's working correctly, the steam will start condensing into the water. Now what that does is it mixes the two, so that high velocity jet of steam is then a high velocity jet of water. From there, we've got this sat in that injector body about there, water going in through there. This is open to atmosphere here. So the other side of this, there's nothing bunging this up, there's nothing forcing anything to go anywhere. So you'll see on the video in a minute, when you start the injector, you always turn the water supply on first, and you'll see water coming out here. You start the steam, and you'll hear the whistling noise of that thermodynamic action happening with the steam condensing into the water. And then the idea is that you start what we call trimming, just turning the water valve down a little bit until you reach a point where the water supply is just enough of the amount of steam that's going through. And at that point, you'll end up with a kind of like a sucky noise that happens, like a gurgling that happens, and you'll know the injector's running correctly. You won't end up with any air being pulled into here, and you won't know any water falling out. And that's what we call an injector running clean, and that's what these wouldn't do. From there, you've got that high velocity jet of steam. So this sits inside the injector like that. So you've got the water cone there. This can move a little bit. It's kind of important, but we'll ignore it for now. You've got that high velocity jet steam and water going through here. This is another taper, so this goes from large to small. The little spiral cone sits inside here, so you've got that change in velocity again up to pressure, and this is again just a gentle taper. The little throat just down there, just beyond the end of this, is a little bit smaller than that. It's again another taper just to slow everything down and build the pressure. So beyond there, you end up with a stream of kind of warm water blowing out the end here, up the pipe and into the boiler. So no pumps involved, not really any moving parts, just interesting thermodynamic theory. Now, the problems we've had with these are that these are worn out. Been very difficult to get drawings for them, and every single one we've measured has been different. So it's very, very hard to pick what are the right dimensions. Doing some reading, the railway arrived at all of this empirically. So they didn't have any design equations, they didn't have computational fluid dynamics or anything like that. They just had experimentation until it worked. So if you want to do some reading, this is called a Giffard injector, essentially, with a few extra modifications, but you know, go and do some homework. So we'll have a look in a minute at Paul actually machining some of these parts. I did some of this, some of these spiral flutes, and Paul did the hard work arriving at the taper turning, which is quite difficult on small parts like this with quite a long operation. But Paul's an amazing machinist and did a brilliant job. So we're going to have a look at that. I wonder if that's blocked somehow.
Let me have a look back in the tank.
So after all that hard work, May has now passed her annual inspection, so she's passed the cold exam, the hot exam, so she's actually passed out to return to traffic. We've got a couple more bits to do to her. She'll be returning fairly shortly into service, so do come and see her. Quick thank you to the new subscribers, welcome. Thank you very much, the channel's growing, so really cool. Thank you ever so much, it really helps. Smash the like button, we've got to say that, the algorithm loves it. Thank you very much, we'll see you soon. Am I doing like a full intro?
Yeah, go for it.
Like welcome back.
Yeah, okay. Ready?